So you can't find the second derivative without finding the first derivative. Just practice perfecting the derivative process. Well, no, we will use the second derivative. We'll get into applications of all this. But once we get into the applications, the idea is that the skill of actually finding these things is like down pat, so that we can actually focus on the application and not making mistakes in the process. So and once we get to the applications, actually finding the first derivative and the second derivative won't be as probably messy. This is taking it above and beyond to a new level just to help you perfect. And then when we actually go to applications, we'll back it up. Zach, can you take your headphones out, please? Josh. Yeah, you could do that. Yeah, there's that. Then we've done a lot of applications already, like finding where there's a horizontal tangent line. But the second derivative applications we haven't even touched yet.
Oh, yeah, that's what I meant. So they give you 3 graphs and they give you
Other than that. Yes, other than that. Yes, technically. But the second derivative will be actually used to find stuff. Okay, so first derivative. Power rule first. Bring your 3 out in front. We get 18x cubed plus 4 squared. Times the derivative of what's inside of that will just be 3x squared. So your first derivative is 54x squared. X cubed plus 4 squared. Any questions on the first derivative? You could. I would generally say this, but this constant might throw people off. I would generally say clean up your first derivative before jumping to the second derivative. It's just going to, generally speaking, make your life easier. That doesn't mean you can't get away with not doing it. It's just my advice. Take it or leave it. Now, the second derivative requires what rule first, Michelle? Nope. Zach? Product rule. Do you see how we have first, second? So your first times derivative of the second. Now the derivative of the second is a power rule first, followed by a chain, because that has a derivative of what's inside. So there's our first times derivative of the second, plus our second, times the derivative of the first, just 108x. So in cleaning up the first piece of our binomial, we have a 54 times a 2 times a 3. 6 times 54 is 324. You got that? 6 times 50 is 300. 6 times the 4 is an additional 24. Okay. X squared times x squared is x to the 4th. So that covers the 54 times the 3, the x squared times the x squared, and the 2. And then we just have an x cubed plus 4. Plus 108x x cubed plus 4 squared. Now, what I could envision them doing to get to the final answer is factoring out a GCF. So, what is the GCF of these two terms? 108x. They both have a 108. They both have an x. They both have an x cubed plus 4 as well. So then what's left of the first term is just 3x cubed. Do we see that? And what's left of the second term? Just x cubed plus 4. To the first power, which technically doesn't need the parentheses then and doesn't need the first power. So then in that set of parentheses, we just have 4x cubed plus 4. Ooh, what did that just do? Now we have a 4 that can be taken out. So 108 times 4 is 432x.
Do we really need this?
So I just took a 4 out of that guy. No, I don't think that. I don't know if they would.
Well, if they went as far as to do all this,
That,
I'm
yeah.
sure they would.
Yeah.
I feel like we should just move on.
But then it just becomes longer. See, so far it just has become smaller. So that's where it's like the length of the answer. Like condensed is just shorter space. So I don't know if they would there, but if they do, then you'd see that in the back. We'll stop there. So, number 2. I'm going to first rewrite this as the secant of pi x, all being squared, so I kind of see it for what it is. Power rule first. So, take me through this, Kyle. First step. Tell me what to write. Shouldn't be thinking about anything here. Are you thinking about what the derivative of secant is? Right, leave everything else the same. Okay. So, but regardless, he followed the power rule first. So he just brought the 2 out in front, dropped it to a degree of 1, leaves everything else the same. Then it's multiplying by the derivative of what's inside of that, which is a secant function. Jack, what's the derivative of secant function? Who can help him? Secant tan. So the derivative of secant is secant tan, so secant pi x, tan pi x, times the derivative of what was inside of that secant, which is going to multiply this by a pi. Okay, so cleaning it up before we jump to a second derivative. We have 2 pi secant squared of pi x tangent of pi x. Now, some people might choose to just start the second derivative and do a product rules because it would be first and second. Some people might choose to change secant squared into 1 over cosine squared, change sine into, or change the tangent into sine over cosine, so it would end up being a sine over a cosine cubed. It's possible in a quotient rule. It's hard to say at the beginning what is going to pan out to be easier, and it may, more times than not, it's a wash anyway. So we'll just jump into product. So we have our first times the derivative of tangent is secant squared of pi x. But there's a chain rule there because what's inside of the tangent is pi x and the derivative of that is pi. So there's my first times derivative of the second, because I'm taking more than just the tangent of x. I'm taking the tangent of a pi x, and derivative of that is pi. Time, or plus, first times derivative of the second, plus second times derivative of the first. So this you may want to rewrite as being 2 pi the secant of pi x squared. So on the outset, when you're taking the derivative of this, it's a power rule first. Bring your 2 out in front. That's going to change it into a 4 pi secant of pi x times the derivative of what's inside of that. The derivative of secant is secant tan times the derivative of what's inside of that, pi. I don't like that one. Alright, so slowly but surely, on this first one, when I multiply this is going to condense pretty nicely. I've got a 2 times a pi times a secant squared times another secant squared times a pi. So overall I have a 2 and a pi squared and a secant to the 4th. You with me? There's my big plus sign. On the next one, as far as monomials out in front, I have a 4 and a pi and another pi. So that's 4 pi squared. I have a secant times a secant, so that's going to make a secant squared. And I have a tangent times a tangent, which is going to make a tangent squared. And I'm going to take out a GCF of what? 2 pi squared for sure. And then secant squared of pi x. Okay, so what does that leave? That's gone, and then that just leaves a secant squared of pi x on the first term, plus 2 tangent squared pi x. From here, it's going to be like, is there anything else to do? Does the final answer look any different? I'm a little, I can't remember because I don't remember my identities other than this one. I always have to think of the other two. But sine squared plus cosine squared is 1. So if I create a tangent squared, I would be dividing by cosine squared on everything. This is just going to give me another version of it. So it's a tangent squared plus a 1 equals secant squared. So there is a relationship between secant squared and tangent squared. That's what I was thinking. What? What do you mean? Secant squared, right, because it's plus. Because it's secant squared plus a tangent squared, which I don't have. So phew, good, because I didn't want to do anything anyway. I don't know if they would, but like if you look in the back of the book and you feel like, oh boy, how did they get that? Kind of just those identities again. All right, we're done. These are so easy.
That's really funny.
Teasing. Okay, G prime. Just teasing. First term, what's the derivative of that? 1/2 x to the negative 1/2, if that, we're kind of leaving it there. So for those of you who aren't seeing that, Taylor kind of thought of it in her head as x to the 1/2, brought the 1/2 out in front, just did a power rule. Jalen went a little bit further when she gave me her answer. So the level at which you can do things in your head is different person to person. So, again, even if you're not there, you can rewrite it first and then visualize that. On the second term, what do we have? Second term, we have a product. So, big fat set of parentheses. Help you organize it. If it's the natural log of e to the something, then they'll cancel. Or if it's e to the ln of something, then that will cancel. But this is a product. So first times the derivative of ln of x is 1 over x, plus the second times the derivative of e to the x is e to the x. So here's the thing, I can clean this up, but remembering that I'm going to have to take a second derivative anyway, I wouldn't want to then put it back, so I'm just going to leave this alone. And I will clean up this thing. Well, and I don't really need the parentheses anymore. It'll just be e to the x over x for this term, plus ln of x e to the x for that term. So this won't be bad on the second derivative, I don't think. It's just going to be a trinomial, so you're just taking 3 separate derivatives. So g double prime of x is negative 1/2 brought out in front is going to be negative 1/4 x to the negative 3/2 when you drop that by 1, plus, I like to do a nice big plus sign so I can keep it organized, bottom times the derivative of the top minus the top times the derivative of the bottom all over bottom squared. I'll come back to it, plus Haley, what do we have to do for the last term? Product rule, again. Now, if you see it, we already took the derivative of this once. Yes? We took the derivative of this, it became this, it became this. Do you follow that? If you see that, you can just copy this down because that is what the derivative of that was. Or if you don't want to go that way, it's harder to see, you can go through the product again, which I will, just so people see it. So first times the derivative of the second plus the second times derivative of the first. Okay, clean up. This first term, negative 1 over 4 square root of x cubed you can do that. We'll do that if we want to. We'll do that next. Plus this fraction x e to the x minus e to the x over x squared plus e to the x over x plus ln x e to the x. Hard to say what the final answer would look like. What Josh was saying on this first term is taking, because you can simplify that. If you're taking the square root of x cubed, that's the same as negative 1 over 4 x root x. That probably will be a term in and of itself. Maybe on here they would get a common denominator. Maybe they would factor out an e to the x. I would say they'd almost definitely get a common denominator with these two. And again, I'm still just guessing based on what my experience has kind of led me into a certain direction. So for these two being added, it would be an x e to the x minus an e to the x plus another x e to the x all over x squared. So overall, we'll have 2 of these. 2x e to the x's minus e to the x over x squared. And I'm going to guess that they would stop there. We're going to stop there. Did you all run into the space for the last one? Jump to the back. This one's just find the second derivative again, but then evaluate it. So, first derivative. How much time do we have? 10 minutes? Liz, get me started. Something to the 1/2. Then I would rewrite it as x plus 4 to the negative 1/2, so you get rid of the fraction altogether. I think that's smart. Follow? Are we good here? So when you bring your negative 1/2 out in front of the x plus 4, it drops to the negative 3/2. That's your first derivative. There is a chain rule here, but it doesn't make a difference if you happen to forget about it here, right? Because the derivative of what's inside is just 1, so you really won't, and sometimes you get lucky if you forget about the chain rule, but always try to apply it. So the derivative of what's inside was just times a 1. So that's it. Again, don't clean this up because you're about to go now and find the second derivative. So bring your negative 3/2 out in front, and you're going to get 3/4. X plus 4 to the, you drop that by 1, it's going to be negative 5/2. Again, times the derivative of the x plus 4, it's just a times 1. So the chain rule. So that second derivative was a piece of cake, yes? Now cleaning it up, it's going to be 3 over 4 times the square root of this x plus 4 to the 5th power. Which, can we reduce this square root because we're taking it of something to the 5th power? Absolutely, but you're just evaluating it, so why bother overworking yourself? Just plug in the 0. So f double prime at 0 is 3 over 4 root 0 plus 4 to the 5th. So it's 3 over 4 times the square root of 4 to the 5th power. So, you know what? Now it would be wise to, because I'm not going to raise 4, well, actually no. The square root of 4 to the 5th power, yeah, is the same root as the square root of 4, then raised to the 5th power. I always tell my Algebra 1 kids, take the square root first to shrink it before you make it humongous, because you don't have a calculator. 4 to the 5th power in your head is not nice. So the square root of that is 2. 2 to the 5th is 32. So 3 over 4 times 32. Okay, so that last example that we didn't have room for. You want a bonus? Go ahead and do it. You've got 6 minutes. When you finish, let me know. I'll come check it. If you get it right, I'll give you a bonus point. No talking.